All right, so in the last video, I was talking about how much work it takes to lift an object up, and I kind of just very briefly went over the example number two about lifting a 200-pound cable that is 100 feet long up to the very top of a building. And so one of the things we did was we took the 200 pounds divided by 100 feet and said it's 2 pounds per foot. And then I kind of just wrote the integral from 0 to 100 of 2x dx, but I never really explained from a calculus standpoint where that actually came from. I just kind of went ahead and said, oh, treat it like a formula and just go with it. So that's what I wanted to do in this video, was explain a little bit more about the calculus side of this thing. So for example, kind of imagine this 100-foot long cable being split up into little chunks, and I'm going to say each chunk is dx in length. Well, what that means is that the force required to lift just that one little section is going to be 2 pounds per foot times dx feet, however long that section of cable is. Again, that's the length of the section. And so if I multiply these together, I get 2 dx pounds of force. And so that's telling me how much force it's required to lift just this one section of cable. And so what I want to do is I want to say, okay, well, if that's how much cable or how much force it takes, what's the work required? Well, that's force times distance. So I'll call this distance x. So we're going to say it's 2 dx pounds times x distance in feet. And so I end up getting 2x dx, and that's where that kind of comes into my integral. So again, it's like chopping it up into little sections of dx length, and then including the distance that it has to travel up to the top. I do want to also mention to you that this problem would be a little bit different if instead of giving me pounds, it gave me kilograms. Because if it gave me kilograms instead, what I would end up having to do is, in order to find the force, I would still have to kind of do this. How many kilograms per meter is it, and how many meters am I using? But I would also end up having to take that and multiplying it by the gravitational constant. So again, I would need to figure out that it was, if I said it was 2 kilograms per meter, 2 kilograms per meter, I would still end up having to take 2 dx, but then I'd still have to multiply by 9.8 meters per second before I can integrate. So that's just kind of how it's different if we use mass instead of weight. So I just wanted to point out again that kind of difference there and where this formula came from. I do hope that this helps. Please feel free to ask me any questions that you have about any of this stuff. I will happily answer them at any time. Have a great day.